4 dice are sitting on the table. Not ordinary ones instead of 1 through 6. They carry a strange scatter of numbers across their faces. And here's what I tell you. Go ahead, pick the strongest one, the die that wins the most often. You get to choose first, and I'll take whatever you decide to leave behind. Then we roll. Higher number wins, 100 rounds of it. And I'll promise you this right now. No matter which one you take, I win. Not by a hair, and not by luck. In 2 out of 3 rolls, again and again. That sounds like a bet I'm bound to lose. After all, you choose first, and you choose the best one on the table. But that is exactly where the trap is hiding. Among these 4 dice, there is no strongest one. There is no ranking at all. There is only a circle. This is not a loaded die, and it isn't a magic trick. It is one of the most elegant traps in all of mathematics, and one of the richest men in the world once said it, deliberately for one of the smartest. It hides inside a single sentence, one that sounds so completely obvious that we never once stop to check it. If A is better than B, and B is better than C, then surely A is better than C, right? We trust that sentence about as much as we trust gravity, so hold on to it tightly. Because for these 4 dice, it is flatly false, and to see how that is even possible, let's start as small as we possibly can, with a single duel, one die against one other. Take the first 2 dice, and let's just call them A and B. Die B is the most boring object in the world. Every single one of its 6 faces shows a 3. However it lands, whatever you do, always a 3. Die A is a bit stranger. Twice it shows a 0, and 4 times it shows a 4. Now let the 2 of them face off. A wins in exactly one situation, when a 4 is on top because 4 beats 3, and the 4 sits on 4 of its 6 faces. If a 0 shows up instead, and that's 2 faces out of 6, then A loses. 4 out of 6, that is 2/3. Die A beats die B in 2 out of every 3 rolls, not by luck, not sometimes this, sometimes that. It is locked right into the numbers, roll them long enough, and it comes back out every time. 2/3, stay with that number for a moment, because it matters far more than it looks. Here's what it really means. Roll 100 times, and on average you lose about 67 of them. This is not a nail-biter where the lead keeps changing hands all night. This is a clear, steady, reliable edge. If you bet on B and I bet on A, then over the course of the evening I quietly take your money. And now comes the part that your brain is about to start fighting with everything it's got. We have one die that clearly beats another one, a perfectly normal world, where there's a stronger one and a weaker one. Now build that exact same idea 3 more times, and the entire normal, orderly world collapses in on itself. Let's do exactly the same thing with the next pair of dice. B against C. Die C carries the 2 4 times and the 6 twice. Against B's 6 threes, C loses every single time a 2 lands on top, and that is 4 faces out of 6, so B beats C. 2/3 all over again, exactly. Then C against D. Die D has the 1 3 times and the 5 3 times. Count carefully through all 36 outcomes, and it works out perfectly cleanly. C beats D once more by 2/3. And now there is a flawless ranking sitting right in front of us. A beats B, B beats C, C beats D, each of them by the very same 2/3. A clean, tidy ladder, A at the top, D at the very bottom. By every rule the world has ever taught us, A should crush D into the ground. So we play the last duel of all. A against D, the best one against the weakest one. This can only end in a massacre. A carries the 4, 4 times over. D carries the 5, 3 times, and the 5 beats the 4. Every single time D shows a 5, and that is fully half of all its rolls. A doesn't stand the ghost of a chance. Count through all 36 outcomes, and here is what is standing at the end. D beats A by 2/3. The weakest die beats the strongest one, just as decisively as every other pairing did. The ladder doesn't exist. It was never a ladder in the first place. A beats B, B beats C, C beats D, and then D beats A. It's a circle, like rock, paper, scissors, except here nobody built the rules that way on purpose. The circle simply falls out of the bare numbers on its own. And your head is resisting right now, I know it is, because better than feels like a law of nature to us. If you're taller than your sister, and she is taller than her boyfriend, then you are taller than him, no measuring tape required, you just know. If one number is bigger than a second, and that one is bigger than a third, the matter is completely settled. This property actually has a name, transitivity, and it sits so deep inside us that we reach for it with everything we compare, including that innocent little word beats. But beats is not a size, it is not a point on a ruler, not a value you can read off. All it measures is who comes out on top more often in a head-to-head, and that kind of relationship is fully allowed to run in a circle without the slightest contradiction anywhere. We just don't see the circle, because ever since childhood we've been trained to expect ladders. And here's the thing, you already know this circle. You've been playing it happily since you were a small child. Rock, paper, scissors. Rock beats scissors, scissors beat paper, and paper beats rock. Now try asking someone which one of those three is the best. The question just falls apart. There is no best one, because if there were, the whole game would instantly be broken. And that is precisely what we are holding in our hands with the Efron dice. Rock, paper, scissors, only hidden away inside numbers. The one and only difference is this: with rock, paper, scissors, nobody ever expects a winner. With dice, we do, because they carry numbers, and numbers, we've been taught our whole lives, always line up obediently in order of size. Here, they simply refuse to. And if you're sitting there thinking this is all just games, dice, children's playground stuff, then here is the circle that decides genuinely real things. Three friends are voting on where to go on holiday: the mountains, the sea, or the city. Each of them has a perfectly clear, perfectly consistent ranking in their head. Now you count up the majorities. Mountains beat sea, 2 votes out of 3. Sea beats city, 2 out of 3. And the city? The city beats the mountains, 2 out of 3. The very same 2/3 as the dice, right on cue. The majority prefers mountains to sea, and sea to city, and yet also city to mountains. There is no winner, no matter how scrupulously fairly you run the vote. And this isn't some made-up puzzle. It's the Condorcet paradox, and it sits right at the heart of every election with more than 2 options on the ballot. So who on earth thinks up something like this? The dice from a moment ago have a name: the Efron dice. They were invented back in the late 60s by Bradley Efron, and he was no hobbyist tinkering away in a garage, but one of the most influential statisticians of his entire generation, later awarded the National Medal of Science. The really clever thing about his particular set: each die beats the next one by exactly the same 2/3, 4 dice, the same number 4 times over, one perfectly even circle. But it was someone else entirely who made them famous: Martin Gardner. In December of 1970, he presented them in his column in Scientific American, Mathematical Games, the column that taught a whole generation to fall in love with mathematics. Gardner simply called them a paradox, right there in the title. And millions of readers stumbled, for the very first time, over the thought that better is allowed to run in a circle. And an idea like this one never stays politely inside the magazine. Non-transitive dice quickly became a favorite curiosity of math fans, of magicians, and of anyone who enjoys winning a friendly bet. Because they are the perfect trap. They look completely fair, they even genuinely are fair, just as long as you happen to be the one who gets to choose first. And traps that look this harmless and this fair will, sooner or later, end up exactly where the stakes are highest. For instance, at a table where two of the most famous men in the entire world were sitting across from each other, one of them was a huge fan of these dice, the other one very nearly lost everything and only escaped because he was so thoroughly, stubbornly suspicious. One of them is Warren Buffett, one of the richest human beings on the planet. The other is Bill Gates. Buffett absolutely loves these dice. He calls them a mathematical curiosity, one that scrambles most people's entire sense of how probability is supposed to work. So he lays 4 of them out on the table, oddly labeled, exactly our kind, and he makes Gates a strikingly generous offer. You choose first, pick the best one you can find, and I'll simply take whatever's left over. Now think back to the bet at the very start. Choosing first sounds like the obvious advantage. You get to reach out and grab the strongest die. But with these particular dice, it is the exact opposite. Whoever chooses first has very nearly lost already, because for every die you could possibly take, there is another one that beats it. And that is precisely the one the second player calmly reaches for. And Gates? Well, Gates is enough of an engineer not to fall for a suspiciously generous gift. He picks the dice up in his hands, turns them over, reads the numbers, and quietly runs the math in his head. And then he slides them right back across the table and says, "You choose first." In the very moment that Gates insists Buffett has to pick first, he has already seen straight through the trap. He has worked out that there is no strongest die on this table at all, only a circle, one in which the second move is always the winning move. And that, right there, is the answer to our very first bet. I don't win because my dice are secretly better. I win purely because I get to choose after you do. But now comes the part where even doing the careful math won't be enough to save you. Because these dice can do one more thing, something a great deal more unsettling. A mathematician over in Cambridge, James Grime, sat down and asked himself, could I make this circle even nastier than it already is? So he built a whole set of 5 dice, each one painted a different color. With 1 die per player, they form a circle again. Red beats blue, blue beats olive, on and on around the ring, until it loops right back to red, all exactly as before, just with 5 of them instead of 4. But Grime had quietly built the dice a second winning chain as well, one that runs in precisely the opposite direction to the first, and he wakes that hidden chain up with one tiny little change to the rules. Each player now takes not 1 die, but 2 of their own color. And you add the pips of both of them together, 2 instead of 1. What difference could that possibly make? You roll your 2 dice, your opponent rolls their 2, each of you adds the pips up, and the entire circle turns clean around. Red used to beat blue, now blue beats red. Every single arrow that pointed one way a moment ago is suddenly pointing the other way. And for the bet, this means something wonderful. Grime lets you choose a single die, takes the one that beats yours, and then he says, ever so casually, you know what, let's each just take 2 of them. Without one single die ever being swapped, the winner flips. He beats you with 1 die. He beats you with 2 dice, and in between the 2, he simply strolls over to the other side of the circle. So why does the whole thing flip? A single die can win on the strength of one rare, very high number. A lucky outlier at the top keeps rescuing it, roll after roll. But the moment you add 2 dice together, that one lucky roll stops mattering nearly as much. Now the thing that matters is the average, and the ranking by average can run in the exact opposite direction from the ranking by a single roll. The die that used to live off its rare outlier all by itself simply drowns, the instant 2 of its many low numbers happen to pile up together. The exception grows rare, the average quietly takes charge, 2 instead of 1, and the whole world turns upside down. And now the thought that honestly hasn't let go of me since. You might reasonably assume that circles like these are rare, painstakingly handcrafted exceptions, a pretty little curiosity and nothing more than that. But they are not. Just take some random dice, with any old numbers scattered across them, and ask the simple question, if A beats B and B beats C, does A then also go on to beat C? Mathematicians have actually worked this out, and the answer is genuinely startling. The more numbers the dice carry, the closer that probability creeps toward a pure coin flip, 50-50. The latter is not the normal case, with the circle as some rare exception. The 2 of them are about equally likely. The circle was there the entire time, sitting right next to the ladder. We just never once wanted to see it. We are trained, all of us, to sort the world into neat rankings, the best die, the best option, the one clear winner at the top. But sometimes there simply is no first place. Sometimes better isn't a ladder that leads steadily upward at all. It's a wheel, one that just keeps on turning. And once you have truly understood that, you quietly let the other person choose first.